Students, this is Unit 6, Polygons, Lesson 6.1, Polygons and Angles. Taking a look at this page, don't forget that you have a date, time, and location, as well as a parent or guardian sign-off. So I'd like you to pause the video, do this problem. We're using no calculators. We're using special right triangles. Pause the video, do this on your own, then restart. Alrighty, welcome back. So we have a 45, 45, 90, leg, 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 root 2. So this is 12 root 2, 12 root 2. Going this way, we times by root 2. So that ends up, watch very carefully, that is times 2. That makes this 24. Here's our short leg to long leg, root 3. Short leg to hypo times by 2. This reads something times root 3 is 24. And our something there is going to be 8 root 3 times 2, 16 root 3. Students, you should be very, very comfortable with this concept. If not, come in for a little extra tutoring. All right, for the next unit, we are finally going to graduate to shapes more than 3 sides. Here are keywords: polygon, convex, interior, n-gon, regular polygon, exterior angles. You need to be familiar with these prefixes. The prefix tri is for 3. So a number of 3 sides, we call that a triangle. Quadri, 4, quadrilateral. Penta is 5, pentagon. Hexa, 6, hexagon. Hepta, 7, heptagon. Octa, 8, octagon. Nona, 9, nonagon. Deca, 10, decagon. Now above this, there are Latin names for things like things with 11 sides and 12 sides, etc. But honestly, they get very long and sometimes hard to pronounce. So above 10, we're just going to use the shortcut 11, gone, 12, gone, 13, gone, etc. You can look up the Latin names if you're curious. Go ahead and Google 13 gone and see what you get in Latin. Polygon, if you have a many-sided shape, then you have a polygon. A regular polygon is something that has all congruent angles, and by implication, if you have congruent angles, you also have congruent sides. It's very important you understand the difference between these two terms, convex and concave. We're going to draw 2 different pentagons. One, 2, 3, 4, 5. That's a pentagon. One, 2, 3, 4, 5. These are both pentagons. But the one on the left is convex. The one on the right is concave. Concave, you can think of it as a side is caved in. The equations you're going to learn about 5 minutes from now only work for convex polygons. They will not be useful for concave. Let's name these. One, two, three, 4, 5, 6, 7. This is a heptagon. Always physically touch sides as you count them. Touch and count. Now, there is a very critical pattern that you need to be familiar with. So we're going to take and we're going to draw the maximum number of triangles from a single corner for each of these. There's a pattern here. So here we have a quadrilateral and a pentagon and a hexagon. We're going to draw the maximum number of triangles from a single corner. So for this, from one corner, we have a quadrilateral. It has 4 sides. The maximum diagonals I can draw is 1, which gives me 2 triangles. And each of those are going to be 180, so I get 2 triangles. Therefore, the sum of the interior angles is going to be 180 plus 180, 360. Now let's move up to our pentagon. From a single corner, draw the maximum number of triangles that we can. Each of these triangles are 180, so I have 3 triangles. So in the margin, if I want to add 3 times 180, I'm going to do it longhand, folks. Learn to try to do stuff longhand as much as possible, please. It's good for the brain. This last one, from a single corner, draw the maximum number of triangles. And this is a hexagon. 6 sides. I have 4 triangles. Now, there are 2 super important patterns here. 2 super important patterns. You can see any polygon. To find the sum of the interior angles, you just find the maximum number of triangles created by one corner, and you add them up. But there's a pattern there, so you don't have to draw this every single time, especially if you get much more complicated things like a 17-gon. For goodness sake, I don't expect you to draw a 17-gon. Okay, look at the pattern between the number of sides compared to the number of triangles. Look very carefully. A quadrilateral has 4 sides, but only 2 triangles. A pentagon has 5 sides, but only 3 triangles. A hexagon has 6 sides, but only 4 triangles. I want you to take about 10 seconds and see if you can articulate by yourself what's the relationship between the number of sides to the number of triangles possible from a single corner. You should have said something like this: the number of sides minus 2 equals the number of triangles, because that's the pattern. 4, 2, 4, 2, 5, 3, 6, 4. So this is true of all interior angles. If I want to find the sum of the interior angles, put an equal sign, we're going to use n to represent number of sides. We're going to use the variable n to represent number of sides. So to find the sum of the interior angles, it's going to be the number of sides minus 2, that'll get me my number of triangles, times 180. Now, if a shape is regular, and I want to find a single one, I take the sum and I divide by the number of sides, sum over sides. We'll take it one more step. N minus 2 times 180 is your sum. Number of sides is n. This only works for a single interior angle and only on shapes where it's regular. Now we're going to talk about exterior angles. Exterior angles. I'd like you to just go ahead and we're going to trace going this way, walk it all the way around, arrows. Alrighty, now we're going to go ahead. I'd like you to sweep the exterior angles right here. Ready? Sweep, have it do an arrow. These are called exterior angles. They're angles created by the extended side, and it's exterior. If you look very carefully, if we were to number these, as here, 1, 2, 3, 4, 5, 6. If you were to put all of these together, you're going to notice that they make a circle. If you put these pizza slices together, they're going to make a circle, and that's true of all exterior angles. This shows the pizza slices, angle 1, 2, 3, 4, 5, 6 in this case. So the sum of the exterior angles is always going to be 360. If I want a single exterior angle and it's regular, again, you do sum over sides. That's going to equal 360 over n. To help you remember this, we have yet another jingle. For the moment, all I want you to do is copy down these equations. I'm going to color code it. If you want to get your quad pen handy, you can watch the colors. Alrighty. These are the equations that are embedded in this song. This song goes to the tune of The Three Blind Mice. If you're not familiar with it, it's the song that goes, three blind mice, see how they run, see how they run. And if you want to get the rest of the tune, you can just go onto YouTube and search for Three Blind Mice nursery rhyme, listen to the tune a couple times, okay? But it goes like this. Look at the finger. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. Try singing it with me. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. So students, as you do the next problems, it's super important you spot and always highlight these 7 key words. Super, super important. All right, so you want to watch out for the word interior and then exterior, regular. And remember, regular means all the angles are congruent. Some, one or each. Is, are, and was, super important. All of these words become equal signs. And number gone, what I mean by number gone, watch out for those prefixes that you should have memorized. Penta is 5, hexa is 6, hepta is 7, etc. So watch out for that number gone. We're going to do these 3 problems together. You're going to do those 3 problems on your own and then check, and we're done here, folks. Okay, step 1, you put your finger on the paper, you read with your lips moving. What is the measure of a single interior angle of a regular decagon? 2, filter the key words. Single, interior, regular, decagon. You come over here, you only have 4 equations you want to worry about. 4 of them, they're right here. We're looking for a single interior angle of a regular decagon. See that word regular right there? See the word each and the fact that it's interior. So we're going to write this down. Always write down your equation. One interior angle is sides minus 2 times 180 over number of sides. Now I account for this word. My n here equals 10. So now I can take where my n is, and you can put a 10 there. So 10 minus 2, that's 8 times 180 over 10. Students, get your hands off the calculator, please. Don't touch the calculator. I'm going to show you some shortcuts here. Step 1, if we're dividing by 10, we can get rid of the zeros. And now it's simply 8 times 18. So, and then always relabel. We just found one interior angle of a decagon. So I'm just going to put decagon underneath equals 144 degrees. Finger on your paper, read out loud. The sum of the interior angles of a polygon is 1,260. What is the polygon called? Highlight our keywords: sum interior, poly. Watch out for that word is. That's an equal sign. Polygon called. Now, super important, anytime you see poly, you don't know the number of sides. That's generic. So polygon peak can refer to a hexagon, a heptagon, a 15-gon, 121-gon. It's generic. So the minute you see the word polygon, you automatically know I don't know my n. Now let's write down the information we have been given. Sum of the interior angles, and we're going to write the equation, sides minus 2 times 180. The sum of interior angles, sides minus 2 times 180. So now we circle, plug, chug. Really important here. I'd like you to circle sum interior angle. Now come up here, look at your information. We are told what the sum of the interior angle is. It is 1,260 equals sides minus 2 times 180. Remember, you don't know your n. That is what you're solving for. We're going to go ahead and distribute there. We're going to solve. We want n by itself. And double check that. That's 0, 12, carry the 1. That's 6. Yeah. Now that's times. The opposite of timesing is dividing. Do not be rummaging around for your calculator here, folks. 1, you can get rid of the 0. A lot of you were trying to figure out, I don't know how many times 18 goes into 162. Great, don't try to do that. At least, how about we reduce instead? We know 9 goes into 18. Excuse me, we know 2 goes into 18 9 times. In the margin, let's do 162 and divide by 2. So I know 2 goes in here, cross it out, 81 times. Now you can handle it. I've got 81 divided by 9. So I just figured out that my n is 9. But wait, there's more. I didn't ask you just for n. I asked what it is called. That is a nonagon. Ready? Put your finger here. Let's read out loud. The measure of a single exterior angle of a regular polygon is 60 degrees. What is that polygon called? Measure exterior angle. It's regular polygon is an equal sign. Really important. The minute you see polygon, you don't know your n. So n equals question mark. We're dealing with a single exterior angle. So we write single exterior angle. That's the single exterior angle equation. Now we circle plug chug. In this case, my single exterior angle equals 60 Put this over 1. Now we cross multiply. Of course, the zeros cancel. So now we have 36 divided by 6, and we get n equals 6. But wait, there's more. I don't ask you just for n, I ask what it's called. And it is a hexagon. Alrighty, guys, this page you're going to do on your own. Pause the video, restart when you're done. Alrighty, guys, let's see. The sum of the interior angles, so I'm going to write the equation. Sum interior angles is sides minus 2 times 180. And it is, that's our equal sign, 1440. That goes over on this side. 1440 equals n minus 2 times 180. I'm going to take a shortcut here and divide both sides by 180 rather than distribute, which is perfectly fine. I'm going to go ahead and divide by 2. I know 2 goes in there 9 times, and 2 goes in there 72 times. Now I know both is divisible by 9. 9 goes in there 8 times, so n equals 8, and it is an octagon. Find the measure of a single interior. And a single exterior of a regular heptagon, so n equals 7. Now, if you look carefully, because I know that 7 doesn't go into 180 or 360 evenly, I know it is a decimal, rather than forcing you guys to do that longhand. At this point, you can use a calculator. So I'm going to go 5 times 180 divided by 7. I'm going to take it to the second decimal place, 128.57. Then let's do 360. Second decimal place, 51.43. So what this is saying is in a certain corner of a heptagon, our interior angle is 128.57. Our exterior angle is going to be 51.43. And what I want you to notice is that it adds up to 180. Last one. It said 4 of the 5 angles of a pentagon. So 1, 2, 3, 4, 5. It's a pentagon. And I am given 100 degrees, 80, 140, 150, and I am being asked to find the 5th angle. Now, this would be so easy if it was triangle because you knew triangles always add up to 180. So you ask yourself, what is the sum of the interior angles? Sides minus 2 times 180. So here, my n is 5. And I get 540. That means all of these angles must add up to 540. So you go ahead and you add the other angles together. So I've got 180, that's 180. 140 and 150, that's 290. So I'm going to minus 470. My last angle is 70 degrees. Check your work, folks. Write notes for things you got incorrect and what you're going to remember in the future.